So section 3-4, we're on the second day out of 3 days. And I don't know that we would need 3 days, but we wanted to make sure that we didn't have a test fall on Friday, because then everybody would have had to take it online, which has not turned out well so far. So we're going to do 3 days on 3-4. Tomorrow has that worksheet that I handed out a while back, and that's what you'll use for homework. And then we're going to do 2 days of review, and Monday and Tuesday of next week will be our Chapter 3 test. But I really like this chapter, and students usually do really well on this test because 3-4 uses all the skills from 3-1, 3-2, and 3-3 at the same time. So we get to this section, and it's like we get 4 days of review because we're redoing this and talking about how to put it all together from the beginning of the chapter. So yesterday, the problem that I ended up doing as the big problem of the day was this one right here about the tomatoes. So today, we're going to move on to this example about the blues festival. And we will only be able to do one problem together. That will be it, and this will be the one. So as we go through this, stop me if you need to ask a question on something. We'll just try to do the best we can with all of this. And like I said, we'll use a little calculator, a lot of brain, and we'll use all the concepts that we've talked about so far in Chapter 3. So we're using a process that's called linear programming. And linear programming has to do with using lines to figure out where your business should be producing. When you have a business, you want to produce so that everything you have sells. Sometimes you end up with a little stock in the back room. You know, there's nothing you can do about that. You couldn't sell them all. What you don't want to happen is to not have enough for your customers that want your products, because they might go somewhere else for your products. So you are screen printing T-shirts and sweatshirts to sell at the Polk County Blues Festival, and are working with the following constraints. Now, constraints are things that hold you back. The big, for instance, is usually money. You know, sounds like a great deal. Let's do this. Let's sell these T-shirts and sweatshirts. Oh, wait a second. We have to have money to buy the T-shirts and sweatshirts before we do this. So that can hold people back. And in this one, we see there's more than just money. You have at most 20 hours to make the shirts. So the festival is coming up. You just came up with this idea, and you realize, I'm working full-time. 20 hours, that's the best I can do. That's all I can give this project. You want to spend no more than $600 on the supplies, and you want to have at least 50 items to sell when you go to the Blues Festival. I would think you'd want more than that, but I suppose for the ease of this problem, they said, let's just have them make at least 50. So how many T-shirts and how many sweatshirts should you make to maximize your profit, and how much would that maximum profit be? Well, over here, they show us that it takes 10 minutes to make the T-shirt. You know, you got to put it's not called a label. Shoot, I can't think of the word right now. Well, what you're going to imprint on it, you put that on, and then you put it underneath the iron, and then you have to give it a couple of minutes to cool so it doesn't start peeling off at the edges. So it takes 10 minutes per shirt. Decal. Now it comes to me. They put the decal on. And these got a good deal from Joann Fabrics. You had a 50% off coupon. They send those out a lot. $4 a piece for the T-shirts. That means selling those, you're going to make a $6 profit. So obviously they're selling those for $10 a piece. The sweatshirts, for those, it takes 30 minutes. It's a different fabric, and so the iron has to sit on there longer, and it has to cool longer in order for that decal to stay attached. The cost to you was $20 to get these plain. You didn't get as good a deal as you did with the T-shirts. And you're going to make a profit of $20. So, where to start? We start with the labels that tell us that we don't have an unlimited amount of stuff. So the first thing they have up here is you have at most 20 hours to make the shirts. But when I look over here, all of this information is in minutes. So I have to make sure it always has the same label. So I'm going to have to take 20 hours times 60 minutes, and that gives me a grand total of 1,200 minutes. Oh, that's hard to see. It's too light. Let me pick a darker color. So I go back through the problem and say to myself, all right, if it has to be about minutes, what do I know about minutes in t-shirts? Ooh, said right here, 10 minutes for every t-shirt. What do I know about minutes and sweatshirts? 30 minutes for each sweatshirt. And then I think, well, they had 1,200 minutes. Were they willing to use 1,300 minutes to do this? And the answer is no. They said, you've got 20 hours and that's it. That's all you can do. So this is going to be a less than or equal to. They could spend exactly 20 hours, but they don't want to go over. Now, one of the other things they talked about was they want to have at least 50 items to sell. So there's my total. Here's my 50. And I'm looking around and I'm trying to see, did they say you're going to make twice as many t-shirts as sweatshirts, 3 times as many sweatshirts as t-shirts? They said nothing about it. So with both of these, we just put a plus, but this one usually messes with people because they're like, I don't know how many they're going to make. Yeah, so x plus y, and this one said they wanted at least 50 items. So this one has to be greater than or equal to 50. That's their hope. Josh, put the phone away. Cost. It's not free. You got that good deal at Joann's. $4 for each t-shirt. $20 for each sweatshirt. And over here it said $600 is your cutoff. So you add these two together, and that has to be less than or equal to $600. Now, one other thing we saw in this information was the profit. And that's, what they really care about. Any business, that's what they care about. And what they said was you make $6 off of each t-shirt, and you make $20 off of each sweatshirt. But this is what they want to maximize. They want to maximize the profit. So that's not a constraint. That's an objective. So they want profit to equal 6x plus 20y. So the others that have the less than or equal to, greater than or equal to, those are things holding them back. They don't have enough time to do anything they want. They don't have enough money to do anything they want. They don't know, but they'd really like to have at least 50 pieces of clothing to sell. So the objective is making the profit. The constraints are 10x plus 30y is less than or equal to 1,200. And here's where I'm going to start my color coding. That one will be my blue. And the number x plus y has to be greater than or equal to 50. So I'm going to go with green on that one. And the cost for x plus 20y has to be less than or equal to 600. And then this is a word problem. So I have to think for a second. Can they sell a negative number of t-shirts? That doesn't make any sense. They can't sell a negative number of sweatshirts. So I call these the obligatory constraints. Because this is a word problem, we are obligated to tell people, hey, you can't have negatives here. Negatives don't make any sense. X has to be greater than or equal to 0, and y has to be greater than or equal to 0. Has to. All right. We start with what we know. These constraints have to be graphed. We have to graph those so that we can see how does all of this come together. So this is where I'm going to color code. My blue one, 10x plus 30y equals 1,200, because remember I'm trying to find the line, not worrying about shading right now. I want the boundary line. And since that's in standard form, I want to find the zeros. We ready? So if x is 0, we'd take 1200 and divide it by 30, or we'd think 30 times something is 1200. What's that something? Most of the time with big numbers, people would use a calculator, but that's going to be 40. That's probably not big enough. We don't sell any sweatshirts, so the y is gone. 10 times something is 1,200. That's 120. I didn't make that big enough either. I need more space to write my big numbers. So for the blue one, I'm going to have to make sure I can go to 040 up and 120 to the right. But I don't know if the other two, my green and my red one, need even more space. So I still have to do those before I can figure out my numbers. For x plus 20y equals 600, so we can get the boundary line. Again, it's in standard form. And I didn't give myself enough room last time. I'm not going to make that mistake again. Give myself some space here. So with this one, if x is 0, the 4x is gone. 20 times something is 600. You get 30. If the y is 0, we're going to take 600 and divide it by 4. Oh, I should start putting these up here so you guys know. You can just use a calculator for these. You don't have to use your noggin if you don't want to. So the first one was 600 divided by 20. And now we have 600 divided by 4. So 150. So now I see my x values have to be even bigger than 120. One more. Oh, I forgot to do the green. Well, then I'll put the green over here. This one we really like. Because if one of them's 0, what does the other one have to be? It has to be. They have to add to 50. So 50 and 50. All right. So up and down, I have to be able to go to 0 to 50. Horizontally, right and left, I have to be able to go to 150. So let's see what we can do down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know we have to have all non-negative numbers. So let's see, and I just scrolled past that after I said it. Have to be able to go to 50 on the y's. 10, 20, 30, 40, 50. So I'm really going by 5s, but I'm just going to mark off by 10s. And going the other way, I had to be able to go to 150, huh? So maybe I'll go with 20 for each one of these. And this time I'm going to label them all because I want us to be able to see each of those numbers. So my X's were t-shirts. And my Y's, I'm going to have to write sideways, sweatshirts. Name for the top. Sales. I mean, you could call it Blues Festival or something too. Here's our sales. Now I have to go back and get my lines color-coded. So my blue was 0, 40, and 120, 0. Solid because it had an equals bar. And that one was the one about time, so I know I don't have an unlimited amount of time, so that's going to shade back towards 0, 0. And again, you can always just test 0, 0, too. You don't have to think your way through all that process. And then the next one was really the green one. I did that out of order. 0, 50, and 50, 0. Ooh, can't get to 0, 50 up here. But that one was the one where you said, I want at least 50 of these to sell. So 0, 0 isn't going to work for that one. That one has to shade out. And then mine was red. 0, 30, and 150, 0. And that one was about money. You didn't have an unlimited amount of money, so that's going back this way again. And last but not least, we know that we had to use x greater than or equal to 0 and y greater than or equal to 0. And I'm not even going to try and put that on here because we know that's what all of this is. And if I add too much, I might start to lose track of where everything is. So now, I have to go back and overshade the region that has all three colors overlapping. Red, green, and blue. Should form a quadrilateral. You should see 4 sides, which means we have 4 vertices that we have to figure out where they are. I love this. I'm looking out and I see you guys, you're shading and you're coloring and getting everything where it's supposed to go. So now I'm going to put my big black dots on the vertices. And I do have some good news. Oh, this isn't black dot. I need to go back one. The some good news is that 2 of these were ones that I actually had to graph. You know, I had to graph 50, 0. And I had to graph 120, 0. But here comes the bad news. That means there are 2 of them left up there that because I didn't use a ruler and I wasn't really careful, I would just be guessing where those are at. And this is not about guessing. I have to figure out where they are. So now what I need to do is get my green, red, and blue lines and work with my calculator to find out where they hit each other. So let me go back up for my boundary lines. This was 10x plus 30y equals 1200. Keep color-coded. My green was x plus y equals 50. And my red was 4x plus 20y equals 600. Oops, knocking stuff around. Now, those are not ready to go in my calculator because my calculator takes y equals. So I'm going to have to solve each one of these. Again, try to keep them color-coded. Solve each one of them so it says y equals blah, blah, blah. Okay, I think I'll continue on and do them all, and then you can look up, because I see you guys are feeling confident and you are just going to town on these. That is good. Double check. Make sure your math is matching my math. Excellent. So are we ready to put them in the calculator? This is where the color coding really shows you, hey, this was worth it. Because here's what we need to do. To find this one up here, we have to graph red and green at the same time and see where they hit. So my first one is red versus green. All right, red and green. Y equals parentheses -1 divided by 5 parentheses x plus 30. Enter. Negative x plus 50. Enter. And now I want to make sure my window matches my little graph up here. So my x's went from 0 to 200. And my y's went from 0 to 50. And I want to graph it, and I want to see where those two hit each other. So I hit graph. There's my red and green. I need to call up Blinky, my hypoallergenic pet cursor. Where's Blinky? Nobody remembers where Blinky is? Blinky's feelings are going to be hurt. Second trace, number 5. Now Blinky's a little lost, so I'm going to use my arrow key to get Blinky up here. Blinky would find it anyway. It's just that Blinky has to do more math if he's further away from it. So enter, enter, enter. Oh, I love Blinky. Look at that. Here's your answer. Boom. What a loving pet. 25, 25. So that was our red versus green. Now there's one more. Like I said, this coloring stuff pays off. This is red and blue. So I can keep my red one in there, but I've got to change the green one to the blue one. All right. Y equals, I can keep that -1/5 x plus 30. And I just erased it by accident. All right, I'll put that in again. And parentheses -1 divided by 3 parentheses x plus 40. All right, graph away. There it is. Call up Blinkster. Second trace, number 5. Enter, enter, enter. 75 and 15. Almost done. Because now what we have to do is take these x's and y's and put them into the objective function. So I'm going to rewrite it here. Because that objective function says, here's how we make our profit. $6 off of the t-shirts, $20 off of the sweatshirts. So if we put 50, 0 in, we're just going to do 6 times 50, which is 300. And then I've got 120, 0, so 120 times 6, obviously that's going to be more, 720. Then I have to do 25 and 25, so 6 times 25 plus 20 times 25, 650. And then 75, 15, so 6 times 75 plus 20 times 15. Aha, jackpot! So let's answer the question. What's going to be the maximum profit? Which one gave us the biggest number? Exactly. So we're going to put that in a sentence and just say the maximum profit of $750 will be made from, no, I already forgot, 75 and 15? A lot of numbers up here. Yeah, 75 and 15. 75 t-shirts and 15 sweatshirts. So they're going to put 20 hours into this, they said, at most. So let's see what they really get paid every hour for doing this. Wow. So they're going to make $37.50 for every hour that they put into this. That's not a bad haul. I mean, I'd say that's something that would be worth it for these people if they have the equipment. I love that problem. You see how everything came together? We had to find the intersection of the lines, like in 3.1. We had to do the algebra that we used in 3.2 when we were solving for y. And then we had to do all the shading that we did in 3.3 so that we could do 3.4, find the maximum profit. Those are cool problems. I also like that it gets coloring because it's almost calming, you know, when you're doing the coloring part. So there'll be like 5 of those on the test because that took us, what, like a half an hour? We'll probably ask you pieces of it on the test, but not have you do, you know, the whole thing all the way through. It takes too long. But they're great problems. So I had best show you the end of this. We'll do this one now because you guys won't be here tomorrow. Is there a maximum or minimum value of a linear function? If it's there, where does it occur? So where have we been looking? Well, wherever we are doing all that heavy-duty shading, that's called a feasible region. But what we've been checking is the vertices, because that's where we get the maximums or the minimums. So it's at one or more vertices of that feasible region. That's what we're always looking for. So that's why we have to go through the whole process. We have to graph the boundary lines. We have to do the shading. We have to see where all that shading overlaps, find the feasible region. In the one we did today, it was a quadrilateral, which means it had 4 vertices. 2 of them, very easy for us to find. We knew where they were. The other 2, we had to do some algebra, had to get things in our calculator to see where they're going to hit each other. So that's where we look for them. Shaded region is called the feasible region. The vertices are where we're going to find our answers. And you get 5 problems again today, and none of them, not all of them I should say, are word problems, start to finish problems. So I am going to grab you, after I hand sanitize here, some sheets of that grid paper, because I was liking what I was seeing up there. You guys were doing some really nice detailed graphs.